Section 5.1, Simple and Compound Interest. What if you wanted to borrow money at 8% interest compounded annually or at 7.9% compounded monthly? Which loan would cost you less? Well, in order to get there, we have to first cover some simple interest first and then move on to compound interest. So simple interest is a type of interest that is charged or paid only on the amount borrowed or invested, and not on past interest. So it only counts on things that are currently happening, not what happens in the past. The amount borrowed is called the principal. The rate of interest is given as a percentage per year expressed as a decimal. And time is the money is earning interest is calculated in years. So interest equals principal times rate times time. So the amount we put in times the rate in a decimal times how many every years we have. To buy furniture for a new apartment, Pamela borrowed $5,000 at 8% simple interest for 11 months. So she's only getting charged interest on the amount of money that she put in, the $5,000. How much interest will she pay? So our principal that she's adding is $5,000. The amount of interest she's paying in decimal is 0.08. And the time, well, 11 months isn't quite a year, so we'll represent it as 11 over 12. So the amount of interest that she will pay is 5,000 times 0.08 times 11/12. So using your calculator, you can take 11 and divide it by 12. Multiply that by 0.08 and multiply that by 5,000, and you should get $366.67 when rounded with how much that she will actually pay in interest for this loan over the duration of the 11 months. The final amount a person ends up paying, the loan plus the interest, is called the future value or maturity value of the loan. So the maturity value of a loan is the principal times 1 plus the rate times the time. So let's find the maturity value for a loan that costs $2,500 to be repaid in 8 months with an interest of 4.3%. So the principal that we're putting in is $2,500. The rate in a decimal is 0.043. And the time is 8 months, not quite a year, so 8 over 12. So we can plug that into our formula. So the amount that we're actually going to pay, the future value, is how much we put in times 1 plus the rate times how long it's in there for. So using your calculator, I would take 8 divided by 12, which will be a decimal, multiply that by 0.043, add that to 1, and then multiply that whole decimal by 2,500. So the amount that we're going to end up paying back is $2,571.67. Find the maturity value for a loan of $11,280 for 85 days at 7% interest. So the amount that we're putting in is $11,280. The rate is 0.07, and the time at which it's in there in years is 85 days out of 360 total days, because it doesn't say months, it doesn't say etc. So it's 85 days out of 360. So I'll plug that in. So we put in 11,280, multiply that by 1 plus our rate times our time. Using your calculator, take 85, divide it by 360, multiply that by 0.07, you'll get another decimal, add that to 1, and then finally multiply that number by 11,280, and you should get 11,466 0.43 is how much they end up paying back for the whole loan. Alicia wants to borrow $8,000 from Robin. She's willing to pay back $8,180 in 6 months. What interest rate is she going to end up paying? So we're still going to use the formula. A equals P times 1 plus RT. We know that she's going to, our principal is $8,000. We don't know what our rate is. The amount that we're willing to pay back is $8,180. And our time is 6 months out of the 12, which is the same as 0.5. So, since that's easy to figure in our head. So now we'll plug them in. We have $8,180 is equal to 8,000 times 1 plus, we don't know our rate. But we know our time is 0.5, so half a year. So if we were to distribute this 8,000 through, because our goal is to get R by itself because we don't know what our rate is. So 8,000, well, half of 8,000 is 4,000 times our rate. Subtract 8,000 from both sides, so 180 equals 4,000 R. If we divide by 4,000, we'll see that R equals 0.045. But we have to transform that into a percentage because we always work with decimals. We have to turn it into a percentage. So we need to move this over twice. So the rate at which she's paying back this money is 4.5%. What I'd like you to do is pause the video and work on this next problem down below. Find the interest rate following the same steps we did above. If we have $5,000 borrowed and $5,243 is paid back in 9 months. When you're ready, go ahead and click play to continue. So the principal that we're borrowing is $5,000. We don't know our rate. We do know that we're going to end up paying back $5,243 altogether. And the time in which we're doing this is 9 out of the 12 months, which is the same as 0.75. So we'll plug them in. 5,243 equals 5,000 times 1 plus R times 0.75. We can share the 5,000. So 5,243 equals 5,000 plus 3,750 R. If we subtract 5,000 from both sides, we get 243 equals 3,750 R. To get R by itself, we have to divide. So R is equal to 0.0648. Again, turning that into a decimal, into a percentage, it's 6.48%. For longer loans, typically over a year, compound interest is utilized. Compound interest is charged or paid on interest as well as on principal. So you're getting dinged or charged for not only the current interest but also past interest that's been paid. So P is the principal, so how much you put in. R is the rate. T is time in years. And then M here and here is the same, so how many times per year? So suppose $1,000 is deposited for 6 years in an account paying 4.25% per year compounded annually. Find the compound amount. So this is how much will be after 6 years. So our amount is equal to the amount we put in, $1,000, times 1 plus our rate is 4.25%. Remember, we turned that into a decimal. So 0.0425 divided by how many times per year? It's compounded annually, so 1 time per year. We bring that 1 up to the top 2. And for how many years? 6. So let's start simplifying here. So this is equal to 1,000 times 0.0425 divided by 1 is 0.0425 to the 6th power. So 1,000 times 1.0425 times 6. So utilizing your calculator, use the order of operations. So you have to do the 6th power first. So take 1.0425 to the 6th power and then multiply that number by 1,000. And we will get $1,283.68. So that's the amount that's going to be at the end. So at the end of the 6 years, that's how much money should be in the account. We'll find out how much of that was the interest earned. Well, if we have a total now of $1,283.68 and we subtract the amount that we put into the account, that means that we earned $283.68 of interest. So we gained $283.68. Find the amount of interest earned by a deposit of $2,450 for 6.5 years at 5.25% compounded quarterly. Find the interest earned. Okay. So we first need to use our formula. Amount equals principal times 1 plus the rate over how many times is compounded a year to the power of how many times is compounded a year times how many years. So the amount we put in was $2,450. The rate at which we're earning is 5.25%, so 0.0525. We're compounding quarterly, so that's 4 times per year. And we're doing 4 times per year for 6.5 years. So this is equal to 2,450. 1 plus, if we were to divide, we would get 0.013125 to the 26th power, 4 times 6.5. So what I'd like you to do with your calculator is take that 1.013125, take it to the 26th power, and then finally multiply that by 2,450. And you'll see that at the end of that 6.5 years, we will have $3,438.78 in our account. But we want to know how much of that is interest. Well, if we have $3,438.78 in the account, and we subtract what we originally put in the account, we earned $988.78 in interest from that account. Suppose Susan invested $5,000 in a savings account that paid quarterly interest. After 6 years, the money had accumulated $6,539.96. What was the annual interest rate? So now we don't know the interest rate which we put into the account, so we don't know our R. So we're going to have to do some manipulation here. So we know that we earned a total of $6,539.96. We also know that we put $5,000 into the account. To continue our formula, we'd have 1 plus the rate over, we're getting quarterly interest, so 4 times per year. to the power of 4 times 6 years altogether. So 6,539.96 equals 5,000, 1 plus r over 4 to the 24th power. Alright, so let's divide by 5,000 here. Our goal is to get r by itself. So we have 1.307992 equals 1 plus r over 4 to the 24th power. So to undo the 24th power, we have to take the 24th root. So using your calculator, take the 24th root of 1.307992, and you should get 1.01125 equals 1 plus r over 4. Subtract 1 from both sides, so 0.01125 equals rate over 4. Multiply each side by 4. So r is equal to 0.045. Again, we want our rate to be in a percentage, and this is currently in a decimal, so we need to move our decimal 2 spots to the right. So our rate is 4.5%. I want you to find the interest rate if $6,500 is worth $8,665.69 after being invested for 8 years in an account that is compounded interest monthly. So pause the video at this time and work through this problem. When you're ready, go ahead and press play again and we'll work through the problem together. The formula in which we're going to use is the same one we've been continually using. The amount is principal times 1 plus r over m to the mth times c power. So we got a total of $8,665.69 when we invested $6,500 in an account where we don't know the rate. We know it's compounded monthly, so 12 times per year for 8 years. So 8,665.69 equals 6,500. 1 plus r over 12 to the 96th power. So let's divide by 6,500 on both sides, giving us 1.33318 equal to 1 plus r over 12 to the 96th power. To undo a power, we take its nth root, so we're going to take the 96th root of both sides. So using your calculator, take the 96th root of 1.3318, giving us 1.003 equal to 1 plus r over 12. Subtract 1 from both sides, so we have 0.003 equals r over 12. Multiply both sides by 12. 0.036 equals our rate. Again, we need to turn that into a percentage, so we need to move our decimal 2 spots to the right, giving us 3.6% equals our rate. Effective rate versus stated rate. Effective rate is commonly known as annual percentage rate, APR, or annual percentage yield, APY. The effective rate is what you are truly paying in interest rate compared to the stated, the rounded rate. So the effective rate formula is as followed. R sub E, so effective rate, is equal to 1 plus the rate that's given, so our rate. M is still how many times per year. on both occasions, and then subtract 1. So find the effective rate for an account that pays 2.7% compounded monthly. All right, so let's find it. We have, let's see here, 1 plus the rate given is 2.7%, so 0.027. We are compounded monthly, so 12 times per year, and then we'll also raise that to the 12th power, and we'll subtract 1. Using our calculator, go ahead and divide 0.027 by 12, and we should get 1 plus 0.0025 to the 12th power, subtract 1. If we add 1 to that, we get 1.0025 to the 12th power. Take 1.0025 to the 12th power and we'll get 1.0273. And if we subtract 1, we'll get 0.0273. Again, this is a decimal. We need to move it into a percentage rate. So 2.73% is actually the effective rate versus the stated rate of 2.7%. All right, so Stacy must pay a lump sum of $6,000 in 5 years. What amount was deposited, the present value, today at 6.2% compounded annually will amount to $6,000 in 5 years? So again, we're still going to use the formula. A equals how much we insert to the account, 1 plus rate over how many times per year it's compounded, to the power of how many times per year it's compounded by how many years. So we know that she wants an amount of $6,000. We do not know how much she put into the account, but we do know the rate at which she's earning is 6.2%, so 0.062. And if we divide that by 1, since it's compounded annually, and 1 times 5 for 5 years. So 6,000 equals P times 1 plus 0.062 to the 5th power, which is 6,000 equals P 1.062. Go ahead using your calculator. Take 1.062 to the 5th power. And we get, when rounded, we get 1.351 when rounded. To get P by itself, we have to divide by 1.351. So when we do that, we will get that she should have invested $4,441.15 into the account in order to end up with $6,000 at the end. Let's find the present value, or the amount deposited, of $16,000 in 9 years if money can be deposited at 2% compounded semi-annually. So using that same formula, the amount equals P times 1 plus rate over how many times per year it's compounded, to the power of how many times per year it's compounded times how many years. So we know she earned, this account earned $16,000 altogether. We don't know how much was put into the account. We do know it's earning at 2%, so 0.02. It's compounded semi-annually, so twice per year, and it's in the account for 9 years. So 16,000 equals P times 1 plus 0.01 to the 18th power. So 1,600 equals, Using your calculator, take 1.01 to the 18th power, which should give you 1.196. And we need to divide each side by 1.196 so that we can get P by itself. And when we do that, we should get, forgot zeros here. So 16,000 divided by 1.196. We should invest into this account to start $13,377.93 in order to end up with $16,000 after 9 years. This concludes section 5.1, Simple and Compound Interest.